Hi, in this video we're going to be talking about inverses and contrapositives. Really quickly though, we're going to need this idea of a negation. Where a negation comes from is inserting a not. It should be right after the verb of a particular phrase. So right here, we've got two rays are opposing rays. If we wanted to write the negation, we would put it right after that are. We wouldn't say two not rays are opposite rays. You want to put it after the are. So two rays are not opposite rays. If we've got this phrase, the polygon is a triangle. Here is our verb right there, is. And then right after the is where we want to put that not. So we could say the polygon is not a triangle. So we're going to need those negations in order to create our inverses and our contrapositives. So the inverse takes those knots and puts them in both of the hypothesis and the conclusion. Both of those things get a knot them. So the if gets a knot and the then also gets a knot. You can see that down in this example here. So right after the is, we get a knot on the interior angles of a polygon, whatever that is. Then it is not a triangle. So both things get those knots. A contrapositive takes the inverse and does the converse of the inverse. So we get the knots and we flip the order. So the knots stick around, but the hypothesis and the conclusion swap places. So this thing goes to the end. See that? And then the not a triangle jumps to the beginning. So not a triangle, not a triangle. So that's jumping around, and the hypothesis is jumping around, the conclusion and the hypothesis. So we want to write the inverse and the contrapositive of this statement. About time we do one. So the inverse, we're going to need to stick knots in both the if and the then part, the hypothesis and conclusion. So we're going to put them right after the verbs. If an angle is, oh, there's our verb. So we're going to put right after the is, not acute. Then its measure is not less than 90. Putting that not right after the verb. Oh, forgot to change colors. Okay. If we want to make the contrapositive, we're going to need to swap the location of the if and then from this statement. So we're going to have to bring this to the end, but we're going to start it with this part. Its measure is not less than 90, making sure that we're swapping around those pronouns in the statement. So if an angle's measure is not less than 90, then we write the hypothesis, but still the negation of the hypothesis with that not in there. Then it is not acute. Cool. So there's our inverse and our contrapositive. The thing we're going to talk about next is this idea of indirect reasoning. Indirect reasoning uses these negations, the inverse and the contrapositive, where you assume that the thing you're trying to prove is wrong, and then you, by working through some logic, discover that like you reach a contradiction that doesn't work. So this actually happened with Sudokus in 2012. What they did is they wanted to prove that a Sudoku puzzle needs at least 17 clues to be completed in exactly one way. But to do that, they assumed that a Sudoku puzzle needs at least 16 clues to be completed in exactly one ways. So that created a whole bunch of like possibilities. They checked all of those, and after some other logical things to narrow down the options, because they didn't have 300,000 years to check, they were able to prove that 16 didn't work, so a Sudoku puzzle needs at least 17. They assumed that they were wrong, that they needed 17 by assuming 16. They found out 16 didn't work, so it must be that 17 was true. So if you were to do an indirect proof, you would need to think about what is the negation of the statement that you're proving. So if you wanted to prove it's snowing outside, you might start with assuming it is not snowing outside. If you were going to do an indirect proof about it snowing outside, you would have to start with it's not snowing outside and then go through things to prove that it actually is snowing outside. If you wanted to prove that this triangle is isosceles, whatever that means, if you wanted to prove it's isosceles with an indirect proof, you would need to start by assuming that triangle ENP is not isosceles. By making that contradiction first and showing that leads to a problem, then you are able to prove that the triangle is isosceles. But in order to do that, you need to get to a contradiction. I keep saying that word contradiction. What does that mean? So, a contradiction is two things that contradict each other. They can't both be true. So, if L and M are skew, then they do not intersect. Those two don't contradict each other. If you're skew, you don't touch. If you're parallel, you don't touch. So, these statements, 2 and 3, don't contradict each other as well as 1 and 2. However, 1 and 3 contradict because lines can't be both skew and parallel. Since that's a contradiction, if we had assumed something and were led to the point that, oh, L and M are both skew and parallel, that would be a contradiction. That would make us say that, oh, okay, what we originally assumed can't be true because we got a contradiction. We can't be skew and parallel.